Excuse me. We'll take questions on the test first, and then we'll get into today's stuff. So, what questions do y'all have from the test? We could do 11. Let me grab it. Where's my... I left my tablet up here, but where did it go? I think I did. Did I leave it next door? I bet I did. Let's see. You're sitting in the dark. Okay. Number 11, you say. All right. Let me grab it. Geometry. Quadrilaterals. Number 11. Oh, yeah. Okay. Number 11 is a kite. We know it's a kite because it says it's a kite. Which tells us something that is very important for this problem. 12, 15, and it's asking for GH, right? Yes, which is this one right here. So it's asking for this one. So because this is a kite, it's got diagonals drawn, right? What is true about diagonals of a kite is the question that we need to ask ourselves. So what is true about diagonals of a kite? There's a few guesses you could make even if you don't know, right? What might be true about the diagonals of a kite? That's true. That wasn't even like a bad guess. That was the guess that we need because they're perpendicular. Which means this guy is what kind of triangle? This is why I don't like teaching small classes first things in the morning. I've been whining about this all year. Don't worry. You're new here. They're used to it. People don't talk. What kind of triangle is it? It's a right triangle. True enough. Thank you. You had pity on me. I appreciate it. It's a right triangle. If we know two sides of a right triangle and we're trying to find the third, what do we use? The Pythagorean theorem. That's Mia's answer. She's the one that always gives that one. Pythagorean theorem. Y'all can do it too. You could even beat her to the punch. You could do it. She won't fight you, maybe. I mean, she might. Pythagorean theorem. What is the Pythagorean theorem? A squared plus B squared equals C squared. To remind us yet again, yes? Which one is C? Because that's really the only one that matters. A and B are either one. Either one of the other two. But C matters, right? Because he's the one by himself. So which one is C? What? In this example, yes, it's not the top one over there. It is the top one. What do you mean by the top one? It's the longest side. It's the hypotenuse, right? All this true? Yes? Still true? Always has been true? So the question mark, is it C or is it one of the other two? It's C. So 12 squared plus 15 squared equals C squared. What do we do to solve that? We square it. What's 12 squared? What? No, that's 12 times 2. What's 12 squared? So that's 12 times 12, right? 144. True enough. What about 15 squared? 225. Now what do we do? What is 144 plus 225? $369. How do we get rid of the squared? What? Yeah, what's that called? See, if we were in Europe, it'd be easier. Well, at least in Belgium. I don't know if it's true in all of Europe. I had a foreign exchange student one time, and she informed me that in Belgium, they call it unsquare, which makes way more sense than square root. Just saying. Wish we called it that, because that would be easier to remember. We call it the square root for whatever the heck reason, I don't know. And then we get C is about something. You got to show it in your calculator. And you get what? Gavin's got this. Quick draw. You don't got this. Where's your calculator? That's crazy, bro.
9.2.
About 9.2 units. I don't usually count off if you don't write units on a problem like this, but it's technically what you should do. All right, what other questions from the test do we have? Okay, that sounds great. I love that. Ooh. Talk about proportionality, shall we? I like teaching. Oh, did you have another question? Did you find something else? Okay. I like teaching geometry. I think geometry is fun. I think it's stretching a good part of your brain and it's very useful to your human existence. But I hate this unit. This is my least favorite unit because it's boring, because it's like middle school math again. But we got this. We can get through it together. We can do it. It's going to be okay. So, let's do it. Unit 7. And that's also okay because I like the next unit a lot. It's lots of fun. It's also brand new, probably. Oh, I do this every year. The teacher edition of this book is split into 2 volumes. So Unit 7 is in Volume 2. So I'll be right back. I'll get a student book and we can do this. That also means that I'm not going to be able to get answers very easily. But I can get Bree to send them to me, and then we'll do the answer part in a minute. Who is calling? Oh. How did you call me at 9:10? Doesn't make any sense. Hey, sorry to bother you, kid. Are you at home this morning, or are you out and about? Okay. Could you find the homework for the geometry 7.1 and 7.2 and send me pictures of the answers to the homework pages? The volume 2 is sitting somewhere. It's either in underneath that table in my bedroom, or it's in the sewing room somewhere. Yeah, 7.1 and 7.2. So chapter 7, lessons 1 and 2. All right. Thank you. Love you too. Bye. Okay. This was Britain's book. All right, so she's going to send me the answers. So normally I would read the answers first, but I don't have them, so I will just take questions on any that you know you have questions about to start. And then once she sends me the answers, I will get them to you. All right. So from 7-1, which ones looked sticky? $38. Okay, let's do it. Okay. Summer jobs. I poured me some water. Where did it go? Disappeared. All right. June. Of 2000, 60.2% of American teens 16 to 19 years old had summer jobs. By June of 2011, 29% of teens in that age group were part of the summer workforce. Has the number of 16 to 19-year-olds with summer jobs increased or decreased since 2000? Explain your reasoning. 60% of American teens, 16 to 19. By June 2011, 29% of teens in that age group were part of the summer work. Has the number of 16 to 19 number increased since 2000? Explain your reasoning. Okay. So this is one of those problems that's a little bit stupid to begin with. There's some of those exist. Because we don't have enough information to answer the question definitively, right? Because we don't know the numbers, right? Because it could be, let's give some extreme example to make it clear what I'm saying. So it says 60% in 2000, right? Isn't that what it says about they're close-ish? 60, where am I? 60.2, right? We'll give it its specificity. 60.2% in 2000. Then it tells us in 2011, 29% had summer jobs. And then it asks us, has the number increased or decreased since 2000? Explain your reasoning. This is one of those problems that you could answer it's increased and you'd be right. You could answer it's decreased and you'd be right, as long as your reasoning was good. Why is that? Boys and ladies, what could be true? What is a hidden number that they don't tell us?
7.2.
That's a great guess, but no. No, it's straight up hidden. There's a number that's invisible. It's not just invisible, but it's not told. This is a great example of how logic, how the side of our brain we're learning in this book is useful to our real life. Thank you for asking about this problem. This is a great one because people in news and in politics and whatever like to throw around all kinds of numbers, but then they don't tell you important ones. Almost certainly because of these numbers, from 2000 to 2011, has it increased or decreased? What is the safest guess based on just what we're given? Is 29 bigger or smaller than 60? Smaller. Oh, you said decrease? I thought you said increase. I'm sorry. Look, we have somebody random commenting something. Let's see. Let's see, shall we? Hi, whoever you are, if you're still here. Wonder if you're the same person that was saying hi on Tuesday. Anyway, so the most logical conclusion is it's decreased, right? Because 29 is smaller than 60. But what did they not tell us? It probably has decreased. That's probably a safe bet. What did they not tell us? What number the percent is of, that's right. We don't know from what they told us how many students or how many youths, right? We don't know what percentage this number has increased or decreased. Because let's say this is a wild example, and it's not this crazy. But let's say, for the sake of explaining the point, let's say there were 1 million of them in 2000, and now there's 1,000. Or did I do that backwards? I totally did that backwards to make my point. Let's say there were 1,000 and now there's 1 million. There was a population explosion. Forget baby boom. This is baby nuclear explosion between 2000 and 2011. It didn't happen, but let's pretend like it did. Then just because percentage is higher, there's still more over here. Probably. We have to do the math to prove that for sure. But I suspect 29% of 1 million is more than 60% of 1,000. Does this make sense? So this problem is more about the answer to this problem is more about explain your reasoning than it is about what the answer is. But for the sake of review and for the sake of just some algebraic reasoning, how do we find 60% of 1,000? What does of mean? What math operation is of? Not division, although we're in the right ballpark. That's definitely not right. We went the wrong way. Multiplication. Of is times. If we're going to times a percent, what do we got to do with it first? We can't times the percent straight up. We got to turn it into something else. What do we got to do? Turn it into decimal or a fraction. Either one will work, right? We're going to turn it into a decimal. What do? Move it over twice. Easy peasy. So this times 0.602, what does that equal? That's easy to do. We don't even need a calculator. If you're multiplying by a power of 10, what do you do with the decimal? Move it. How many times do I move it? I move it not 10. I move it the same number as the zeros. So 3 over. So in this example, in 2000, there were 602. Same thing with 29. To get it as a decimal, we move the decimal place over twice. So multiplying that times 0.29. To multiply times 1 million, how many times are we going to move the decimal the other way? 6 times. 1, 2, 3, 4, 5, 6. 290,000. So in my dumb example, to make a point, there's way more in 2011. And we also remembered how to multiply percents. Good job. Go team. What other things looked, let's see. Is there anything else?
that is, let's see, in June 2011, how many 16, 19-year-olds would you expect to have jobs out of 700 in that age group?
So that one is more concrete, right? So for that one we now have enough numbers. So what are they asking us to do? Which percent are we using, the 60 or the 29? The 29, because that goes with 2011. 29% of 700, right? So 29% of 700. That one we can't just move decimals because of the 7. Dang it. What's 0.29 times 700? $203. So you could expect 203 people.
Okay. What other questions do we have? I know which ones I'm going to do if y'all don't have any that you're scared of. Let's see, did she send me those pictures yet? Because I know which ones you're going to make a mistake on. Oh. She tried calling me back. All right, I'm going to read you the answers. You ready? What numbers did I assign? 18 through 40. Come back. Number 18 is 63, 45, 72. Number 20 is 56.25, 45, and 78.75. Number 22 is 3.2. Number 24 is 5. 26 is 10. Excuse me. 28 is 5. 30 is 6,080 pesos. 32 is 1.6. What did we go through, 40? Okay. 32 is 1.6 and negative 2.6. Number 34 is 490 feet squared. Number 36 is 22 feet. Number 28, they made the claim decreased for the same reason that it said, because this number is littler than this number, which, fair enough. And 203, which is what we just agreed with. Great. 49 students. All right, now that you know answers, what questions do you have now? They gave it as a decimal. It's 1.6 and negative 2.6. 32 is one that I think we almost certainly will need to do. If you remember how to do a problem that requires some of the algebra bits of 32, you probably barely remember it, because if you learned it in Algebra 1, you probably barely learned it. You just barely learned so far how to factor, and so you probably don't have a ton of practice. By the end of Algebra 2, you'll be a pro. You'll be able to do it in your sleep almost, because you'll factor so much. But why is that an answer? I've read it twice, but I'll read it again. You ready? 32, the answers are 1.6 and negative 2.6. It has two answers. Let's do 32. Oh, and what it was a fraction, it would be 1 6/10, which would be 3/5, and -2 3/5. You have to convert to improper to figure that out. Let's do it. We're going to do it anyway, so don't stress. You will get doing it the way we do it, we'll get a fraction. I don't know why they write a decimal answer. I think that seems silly. Oh, it's probably because they put round to the nearest tenth. But we're going to ignore that because decimals are ugly. So it says solve the proportion. Round your answer to the nearest tenth. So, how do we solve a proportion? Let's start there. Cross multiply. True enough. We could do some simplifying first, but we'll go ahead and start just with cross multiply, because why not? Now, when we cross multiply and we have more than just a number, what do we got to do with it? Put it in parentheses, or distribute it, or go ahead and distribute it. Either way, we're going to wait to distribute it on this problem, and I'll show you why in a minute. If you didn't see to do that, you could still get the answer. You just might be a little bit more difficult. So we've got 10 times x squared plus 3x minus 12 equals 20 times x minus 4. You got that. Oh, I say we're going to wait to distribute. We don't want to do that because we got to do some other things. Okay, so you're in geometry, not algebra 2, right? Did you take algebra 1 last or algebra 2 last? I did. You've done algebra 1? Or who knows? Because you were in a different country. Okay. So we've got a squared in there, which means we've got a quadratic equation, which means we got to solve this using a method like the quadratic formula or factoring. In order to use any of those methods but one, you have to have everything on one side and 0 on the other side. So that's really our first goal in this problem, is to ultimately get everything over here and a 0 over here. And we're going to end up with some like terms, right? Because we've got some x's here, we've got some no x's, so we're going to want to combine stuff. So unfortunately for us, we are going to want to go ahead and distribute, right? Because we can't combine stuff if they're not like out of the box. So let's distribute. What's 10 times x squared? Thank you. What's 10 times 3x? 30x. Thank you again. What's 10 times negative 12? It is negative 120. 20x. I got the hard one, don't worry. What's 20 times negative 4? Negative 80. What now? So kind of, right? They're separated by an x, so we gotta get them on the other side. So we're combining them, but by moving them. So how do we move that 20x to be over with the 30x? Subtract it. And I stress this point because even at this point in our math career, sometimes it's easy to accidentally not make this mistake and either always change the sign, whether it's on the same side or different sides, or never change the sign. But if we're moving it from one side to the other, you got to do the opposite, right? But if they're on the same side, you stay the same. What is 30x plus negative 20x?
10x, true enough. And also go ahead and do the 80. How do we move the 80 over? Add it. Easy peasy. Negative 120 plus 80 is what? Negative 40. Okay. What could we do now? What? Oh, do like square root? Is that what you're saying? Oh, well, good, because that's wrong. We can do something with the tens. We can. We can actually make our life much easier in this particular problem. Because we put a 0 on that other side. What would happen if we divided everything by 10? Would the problem get simpler or no? Why don't we try, since y'all are all stone-faced? Oh, I didn't hear you. And nobody else said anything, so it's okay. If we divide everything by 10, sometimes I ask trick questions, but rarely. So, I mean, you can be safe. Answering simple questions with simple answers. What's 10x squared divided by 10? Let me put it to you another way. What's 10 divided by 10? That's a great statement, but wrong. It's 1, not 0, right? So 1x squared, which is the same as x squared, right? So 10x divided by 10 is what? Ten divided by 10 is 1. So there's only an x left, right? 1x, so plus x. What's negative 40 divided by 10? Negative 4. And 0 divided by 10 is 0. When we have a quadratic all on one side equal to 0, our first instinct should be, and I'm saying this mostly to project to next year in Algebra 2, right? Because we don't see very many quadratics in geometry. It's very rare, right? But next year you're going to see it a lot. When you see a quadratic, and it's a quadratic because it's squared, the biggest thing is squared, the first thing you should think is this is going to factor. This one can't, and I'm going to remind you how to factor, and we'll show you why it can't. Okay? But that should be your first thought, is this is probably going to factor. Okay? So to factor, you factor a trinomial, you make 2 sets of parentheses. In the first slot, you put what multiplies to get the first one. So x times x is x squared. Right? I'm sure you have all seen this before, even if you don't have a lot of practice, right? Am I right? Yes, I am right. Okay. Then in the second slot, you put 2 things and multiply to get the 4. So you have a couple options. You have 2 and 2, and you have 4 and 1, right? You have 4 and 1. And what you are trying to figure out is whether you can add or subtract to get the middle one. So we multiply 4 times 1, we get 4, and 1 times 1 is 1. Can we add or subtract to get 1 with 4 and 1? Yes or no? No. 4 plus 1 is 5. 4 minus 1 is 3. 1 minus 4 is negative, etc. Right? Can't happen. So try your other option. Put a 2 and a 2 here. 2 times 1 is 2. 1 times 2 is 2. Can we add or subtract those numbers to get 1? No. We've exhausted all of our options. What is another way we can solve a quadratic? Does anybody remember from Algebra 1? another reason why they did decimals. I was thinking it's going to get a pretty fraction, but it's not. Does nobody remember? Everybody's afraid to speak today. We use the quadratic formula. Or you can complete the square. But if you remember one, it's probably the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. In order to memorize this formula, there's a lot of different ways. One is straight up flashcard, look at it for hours and get there. You could do that. You could also, I'm not going to do it for you because this is being put out live on the internet, and I can only handle so much embarrassment. Okay, that's probably not quite true, but time's sake or something. You can sing it to Pop Goes the Weasel. You try it in your head, it totally works. You can do that. That's an easy way to do it. Or if you want an even cooler way to sing it and memorize it, this teacher lady, I can't remember what her name is, does a great version of Crank That Quadratic Formula. If you look it up on the YouTube, it's a great way to memorize this formula. You'll memorize it with a couple of playthroughs, easy peasy. Great. So this is the formula. What are the A's, the B's, and the C's in relation to this? My day is bookended in opposites. My first class of the day, I can't get to make any noise. My last class of the day, I can't get to shut up. It's quite fun. The A is the one that is the coefficient in front of the x squared term. The B is the coefficient in front of the x term, and the C is the constant. Okay. So A in this case is 1, B is 1, and C is negative 4. So we're going to just shove those in here. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. B is 1. A is 1, and C is negative 4. A is still 1. So to simplify this down, what do we need to do first? Yes, inside the radical. What specifically? Actually, we can do two things because they don't affect each other. We can't subtract first. That would come at the end, right? That's at the very bottom of the order of operations. How about we square the 1? What's 1 squared? 1. Good job. We can also go ahead and do that multiplication, right? What's negative 4 times 1 times negative 4? That'd be plus, right? Times 16. And it's positive, right? 2 times 1 is 2. What's 1 plus 16? Did you say I don't know? Most of the time in like an Algebra 2 class, if we're doing something like this, you would circle this and move on with your life. But for two reasons, we're not going to do that. One, geometry, we're more interested in like measured numbers, and so usually we get decimal equivalent, right? So but that's not really a good enough reason by itself. The other reason is it says round to the nearest tenth, which means it wants decimal numbers. So we got to take that irrational square root of 17 that is looking real pretty right now and turning him into something ugly. So we got to shove square root of 17 in your calculator and push enter. $4.1. All right, so we got plus or minus in there. What's plus or minus mean? Well, it means it's both. If you have a quadratic, you can have two answers. You have two real answers, one real answer, or zero real answers. We don't have to stress about all that. We're not doing algebra, we're doing geometry. So we gotta split this into a couple of different things. We gotta split it into -1 plus 4.1 over 2 and -1 minus 4.1 over 2. And this is a scenario where the order of operations is a little bit fuzzy in a way, right? Because you would think you would do division first, but this is, when it's in a fraction, it's kind of like this is in parentheses, and parentheses comes first, right? So we got to take care of the top first. So what is -1 plus 4.1? 3.1 over 2. What is -1 minus 4.1? True enough. And we can't have this ugly compound fraction nonsense, so we got to divide it. So what's 3.1 divided by 2? 1.6 if we're doing the tenths, right? 0.6. And then -5.1 divided by 2 is what? 2.6. Negative, right? -2.6. This is an example of a problem in geometry. This is a rare example. Usually, once you get to the algebra phase, it's easy. Solve for the equation, move on with our life. If you get the right equation, you get the right number. No big deal. But this is a rare example where in geometry, the algebra is the challenging bit. And you got to remember you have to remember all of those puzzle pieces from last year and not just last semester. On a test, I wouldn't give you one with a quadratic on it. I would certainly give you one that looked something like maybe this or something. I would certainly do that where you have to distribute the 20. But I wouldn't give you one with a quadratic on a test. What other questions from the homework do we have? Well, let's do 28. We might also need to do one of 18 or 20. Did y'all get those okay, or do we need to do one of those?
We don't even start as early as public school does. Y'all are still asleep. That's crazy. Isn't homeschooling fun? All right, what should we do? Where's our step one? Cross multiply. Sounds great. If you can remember to do it correctly, you can probably go ahead and distribute when you cross multiply. But if you're making careless mistakes on these, I would do it in 2 steps. That's just a general rule of thumb. I say this kind of stuff all the time. The reason I say it all the time is because usually, eventually, students listen to me and start doing the thing. And when they do, it's like, oh my gosh, I should have been doing this the whole time. So much fun. It's great. General rule of thumb. If you are making careless mistakes, stop skipping steps. Also, if you're making careless mistakes often, make your work neater. It won't erase them, but it will help. I'm 120,000% sure, which is pretty sure. So, let's go ahead and cross multiply. We'll go ahead and distribute because we got all our eyeballs to check. If I make a mistake, that's when you have to talk. If I accidentally write something wrong on the board, you have to say so. That's the rules. Otherwise, get out. No, just kidding. All right. What is 2 times 4x? 8x. And what's 2 times negative 2? Negative 4. Good job, you did it. Oh, it wasn't even the first time. Why am I cheering? Everybody's acting, I've been whining today, even more proportional than normal. Maybe because we're talking about proportional, I don't know. Or maybe I woke up on the wrong side of bed. I don't know. I have no idea. But everyone has actually spoken today, which is not always a sure thing in this class. Okay, so what is 4 times 3x?
12x.
Thank you. And correct. What is 4 times negative 6? Negative 24. In this class, even though the class is tiny, I should start doing the popsicle stick thing. Gavin, what is, or whatever. Any of y'all done public school? Any of y'all? I know you did a private school for a while, right? You did other school in classes, right? Was it public or private, or is that a thing? Who knows? It's a good question.
Think it may have been.
I don't know. But it was with other people. So you've had classes. So you may have had strategies like popsicle sticks and nonsense. Who knows? What about you, man? Have you ever been in public school or private school?
I went to private school for like 2 days.
For like 2 days? That's funny. In Lubbock?
Yeah.
Was it? I was going to say, was it Southcrest? That's funny. Nice. I already know you. You haven't done any of that. Okay. What should we do now? Still, yes. Okay, how do we do that on this one? Subtract 12x sounds like a great idea. I don't know why you whispered it, but it's a great idea. We could subtract the 8x. That would also be fine. It would give us a positive number, but it would put an x on the wrong side. It's not really the wrong side, but it's not how we usually do things. What is 8x minus 12x? Negative 4x. True and true. What now? Add the 4. Sounds good. What's negative 24 plus 4? Negative 20. Now what? How? What operation are we doing? Adding, subtracting, multiplying, dividing, what?
Are you're just saying the negatives go away? Is that what you're saying? Because you could do that.
Yeah, whenever it's on two different sides of the.
Yeah. So we can't. And so you can. So your logic is logicking. Your math is mathing. What you're doing technically is doing something like this. That's what's causing it. But yes, they're both negative. Think poof. That's true. Totally true. Not false because of that. Now what? Divide by 4. It's true. And so x equals 5. Easy peasy. How we do it? Might have time for one more. Any that y'all want to see? Well, just because it's a little different, let's look at 18. 18 says the ratio of the measures of the 3 angles of a triangle is 7, 5, and 8. What other information do we need to already know in order to solve this problem? We need to know that the sum of the angles in a triangle is 180. So A plus B plus C is 180, right? If they're the angles. Which actually, this is geometry, so I shouldn't be sloppy. A plus B plus C. Now they're points. Is 180. So what math should we now do with this problem? Substitute what?
7, 5,
Into here? Because if we do that, then that's the problem, right? Because 7 plus 5 plus 8 doesn't equal 180. We broke it. Oh no. Indeed. You see why I thought we might have a question on this one? What could we do with 7 and 5 and 8? Because there's something that's good on the board that we just added. Okay, yes, we could. That's okay. So I like your solution even better than what I was going to propose. Your solution is great. So what you're saying is 7 times something, and then times the same something, and times the same something equals 180. Because this is a proportional relationship. Your way is more high school than what I was going to suggest. I was going to suggest a more middle school solution, which was going to be to set up a proportion. I was going to find the sum, 7 plus 5 plus 8, which we're going to do anyway right now. And then I was going to write that proportion as a fraction equal to another fraction. You moved into the algebra 1 way of doing that. You kind of skipped a step from what I was doing. Not on purpose. You did it great. But yes, this totally works. So let's solve this algebra equation, because this is now easy. What should we do? 7x plus 5x plus 8x equals 180. So what now? True enough. True enough. 20x equals 180. Which, if we were talking in algebra terms, we just figured out, actually we're about to find out what the constant of proportionality is, which is how we talk about it in algebra. What now? Divide by 20. What's 180 divided by 20? 9. Now, this is another type of problem where we would be tempted to simply circle this and move on with our life. That's not what they're asking for. What is the final thing we need to do to finish this problem out? Yeah, multiply it times all the things. What's 9 times 7? 63. Does it give us the units? No. And what's 9 times 5? 45. And what's 9 times 8? 72. Okay, kids, go home, find somebody that loves you, give them a hug, do your math, see you Tuesday. As my old geology teacher used to say on Fridays, stay out of pool halls and honky tonks. Not geometry teacher. What is it called? Geology. One of those geo things.